there we've got a platform design. Let's look at the volumes. I do so by going to strings, string editing, and selecting the volume option. Specify which string family I'm working with. I can go and specify topsoil to strip, as well as a compaction factor, which not a lot of software programs can do. With the topsoil to strip, it is the depth of the topsoil to be stripped before fill takes place. It is not used during the balancing calculations, but is used when final volumes are reported. Looking at the compaction factor, this is the factor to be applied to the cut material before being used as fill. A factor of 100 gives no compaction, less than 100 gives compaction, and then greater than 100 gives bulking. And I should also mention that with your string volume, Civil Designer uses the triangulation method. I'm going to go and update these volumes for explanation purposes, and then click on OK. Specify where you want the results, and then use this output window on the right hand side. Looking at the results, we've got the unadjusted volumes as well as the areas, and then we've got the volumes adjusted for the compaction and the topsoil stripping. Now what I've done for explanation purposes is I've gone and selected that, copied it, and then went to Excel, right click and pasted it. Then I've also gone and put in the values here so I can use it for explanation purposes. What you're about to see also applies to your road calculations. So we got the total cut, and this is the unadjusted volumes. We got the total fill, and then we've also got the area. Then we've specified no compaction, so I've put in 100% there, and focusing then in on the 100 mils of topsoil. So I've taken the total cut area and I've times it by the 100 mils to give me the total topsoil stripping volume in cut. I've then taken the total volume in cut and I've minused the topsoil stripping volume. So if we were to look at the equation there, just to reiterate what I've pointed out, same applies to the topsoil stripping volume in the fill condition. Thereafter, if you want to see if you've got excess cut or fill, you take your fill minus your cut and you're left with the resultant. So that applies then just to the topsoil. Then looking at your compaction factor of 95%, you can see I've gone and put in 0.95 there. Looking at the equation, you take your original unadjusted cut volume and you times it by the 0.95 to give you your result. Your fill stays the same because your fill isn't influenced by your compaction factor, and then you take the one minus the other to, in this case, get a full shortfall. Then put in the topsoil of 100 mils as well as the 95% compaction factor together. Looking at the equation again, you take your topsoil resultant volume and you times it by the 95%. Full volume is the same as the full volume used after your topsoiling has been added. Again here we go and calculate the difference between the two. So I thought for explanation purposes it would be good to first of all calculate your topsoil stripping, then put in your compaction, and then show you the calculation with both scenarios calculated. Closing Excel, going back into Civil Designer. If you now want to optimize your cut and fill volumes, you can go back to strings, string editing, balance cut and fill volume, go and specify the optimization difference. In this case, let's go and put in 5%, which would mean your cut and fill will be within 5% of each other. Again, go and specify topsoil to strip and a compaction factor. Click on OK. You can see the different colors represent the different cut and fill. So what Civil Design has done is it's taken the parent platform and it's made it higher and lower. It's calculated the volumes until those volumes are within 5%. Click on OK again. Previously we had unadjusted cut of close to 6,300. Now we got close to 57,800. So you can see quite a bit of calculation being done behind the scenes. Nice thing about this function is if I were to go and press Ctrl Z on my keyboard, the optimization functionality is removed.